Hi there. Thanks for tuning in. I'm Stone Coyote, and today we're going to be doing a very basic tutorial. Today we're talking about the size map. And if you're an Unreal beginner or even a novice, you know, someone with a little bit of experience, maybe a game or two published on itch or Steam or whatever, you might not be optimizing enough to have really looked at the size map. And let's get into the engine here. There we go. Okay. And in Cool Water here, I'm gonna show you some stuff about the size map. So I have my asset. It's the base actor. It's the actor class for any creatures. So the creature rat is gonna inherit from creature class. Okay, now let's go ahead and right click this and this thing called size map. You can also get some fun stuff off of reference viewer, but that's not what we're playing with today. So we open up the size map and you see it's referencing, well, the game is, I have it set to game memory size. You can set it to game and editor references as well as disk size, whatever you need to know, but this seems like a pretty good indication. Okay, so what this is telling us is the creature base is taking up 67 megabytes of RAM, megabits, whatever, of RAM every time it's loaded. And anytime it's loaded, everything inside here is also loaded. My first person character, it's always loaded whenever this creature is loaded. There's 6, 7 creatures in one of the bigger maps. The game instance is always loaded because I was using terrible practices for game instance maintenance, I guess. I don't know. And you've got all these widgets that are always in memory as long as any creature is in memory. That 67 megabytes started looking pretty darn big to me. So this isn't a tutorial where I'm going to show you how to build something from the ground up. This is a tutorial where I'm going to just let you watch along while I fix the errors I have made and show you how to avoid having this gigantic size map. Because, whoa, where'd you go, giant size map? Come back, giant size map. Oh, there you are. Because that's just not... Here, check it out. Anyways, I was going to show you with man-made objects. This campfire is actually what I'm using as a sort of data center. It's the thing everything's interfacing with to store data, save the game, and all that stuff. Because I was using the game instance, and apparently you really shouldn't do that. Let's check out the size map of this thing that's talking to basically everything. Whoa, 6 megabytes. Now, I dropped a couple of clues on how we achieved this difference when I was explaining what the campfire is. And you see here, it's half of its size is the actual models and textures and whatnot. Half of its size, almost half of its size, third of its size, I guess. I don't know how to do advanced fractions. I'm American. But this is all of the visual effects, the smoke, the fire, all that fun stuff. Over here is that man-made object base. Remember how I said it inherits from a parent? It's a child of the man-made object, which in itself doesn't have a whole lot of outward references. Here it has a UI reference, a widget. It's actually, like I said, it's sort of like a data center, so it's actually talking to all of the widgets all the time, which probably isn't like ideal, but it's pretty trim. The only other thing that I can think of to make it more efficient with the widgets is to make some kind of like widget caller, but that I'm not too worried yet. When that 500k per campfire turns out to be a bad thing, we'll worry about it then, right? So that's the only thing referencing those widgets. But this creature base, remember how it was referencing basically everything in the world? Well, let's look at a few things. First off, you have it casting to a first-person character. Now, there's nothing inherently wrong with that. I mean, it's a thing you can do, right? But instead of that, I have this little function over here that I made in the campfire. I'll show it to you, don't worry. Speak with player. Now this seems to be a much more efficient way to do the things I'm doing. Let me be OCD real quick about my grid. Okay, so what this does is it's not a super fast task. There are probably maybe more efficient ways to do this. I'm still a beginner after all. But what it does is it looks for any actors with the BPI player interface. So yes, it's going to ping all the actors, but that just takes a couple of moments when the game starts or when I have to do this specific thing. And what that does is when it pings them, it goes through here, and the player itself, through the interface, API, what are we checking for? Yeah. Interaction. I set up this toggle interaction availability function on the interface, and now we just connect the local variable to that. Get rid of that. Do that. Okay. We're going to do something similar down here. So speak with the player. Exam, toggle examination availability. That up here. Tell it to be that. And done there. This one, I was checking, is it a first person? But guess what this does? It doesn't actually say it. This causes a link to the first person actor. So instead of is a, we do a does object implement interface. Select the player interface. You can see other interfaces I have here that allow different toggle gates or whatever you call it. But we're looking for a player interface. Save that. Don't think there are any other issues on this, so let's see this again. 700k now. So you get the concept of what I'm trying to explain, extol, teach, manifest. I don't know, but that you get the gist of what's going on here. And I will now show you, oh, another thing. Blueprint libraries. They are something that I got really comfortable with. Pardon me. Something I got really comfortable with, and I decided I was going to use them a lot. They're really easy to access, but guess what? They also cause dependencies. So we have the creature base, right? We saw that has a size map of 738k. Now if we What's one of my interfaces? Check player location. See, it's great. You can just call them from anywhere. But watch this. Whoa! Now, it's connected to everything that uses that function library. And that is a complete nightmare when optimizing stuff. So, I am currently in the process of rethinking how I use function libraries. The most obvious and logical choice, I don't know. These dependencies here make him a sort of bummer. It's just so much easier to set up that call system. Let's get rid of that. And just to show it off again. Oh wait, I don't have to do that. Or do I? And there you have it. You have a very, very tiny reference to the interface itself. But that's it. It's just so much more efficient looking. I mean, the game runs a ton better already, and I'm only about halfway through finishing this up. But anyway, the actual interface isn't all that complicated. You have, when you make it, you'll just get this thing, and you can click on it. And you can't do anything in here. It's read-only. You can't actually make stuff in here. So it's a really confusing concept. At least it was for me when I was starting out. But anyways, you click on the actual function, and you get to put inputs and outputs. Outputs changes the way it works a little bit. It's a little more nuanced, but if you just put inputs, item to add, new inventory in this case, you get, wait, where is it? Where the heck did it go? Yeah, that's it. The inputs, where's that damn input? Yeah, here we are. Here we are. See, here it is. And when you activate that on a blueprint with that interface, you either double click the interface over here, or you can interface and select them from here. But once you do that, anything that uses this, so, you know, the add item, remove item. Where do I have? Up the crate. When we use the function add item, we give the new item. If you don't use structs, they're a little risky, but as long as you don't nest them too much, you can set members, and that only changes that one item in the struct. If you set the struct and you leave some blank, it sets them as blank. Just a little side tip. But that gets passed through to the new inventory when I use it, and that goes to anything using this interface that has this. So it will come through here. This guy, I think. Well, whatever the heck it is, it'll come through here and set the stuff in there. So these two things don't even know each other exist, and yet they're still able to communicate. And that's going to save you a ton on performance and disk space. I mean, geez, the disk space difference alone. Let's go ahead and look at Cave Crate. Disk size 21 megabytes. We go to Sega Meteor. Disk size is 275 megabytes. Because this one's all still wrapped up in all the... I mean, just look at how much stuff is talking to each other. So you really save on a lot of everything by making sure you use interfaces anytime two things are going to be talking. I still have the campfire and the first-person character communicating directly with each other because there's so much back and forth between them that it's simpler from a logistics perspective at the moment. But as I get more comfortable with interfaces, yeah, this is a complex character. I don't know. Yours might be more complex. Try and keep things tidy when I can. But there you have it. That's a basic rundown of why you should be using more interfaces if you aren't already. Come back. Alright. This has been a shorter video, but I hope it was able to help you get a lot more efficient in your games. Thank you for tuning in.